All right, let's dive into one of the most classic gotcha questions for any Java developer. Seriously, this is a topic that has sparked so many debates and confused even really experienced programmers. We're going to get to the bottom of how Java passes arguments to methods.
So let's just put the question right out there, plain and simple. When you pass a variable into a method in Java, is it passing the value or is it passing a reference? It seems like a simple question, but trust me, the answer has this little twist that trips a lot of people up.
Okay, so the short, official answer? Java is always pass by value. End of story, right? Well, not so fast. If that's true, then why does it feel so much like pass by reference when you work with objects? You pass an object to a method, you change one of its fields, and poof, that change shows up back in your original code. That's the paradox we're going to unravel today.
To really bust this myth, we first have to be crystal clear on what these terms actually mean. So let's establish some ground rules and get our definition straight. So, in a pure pass-by-value system, the method gets a copy of whatever you pass in. Any changes you make to that copy inside the method have zero effect on the original. It's totally separate. But with pass-by-reference, the method gets the argument's actual memory address. It's working with the original, so any change is permanent. The best way to think about pass-by-value is the photocopy analogy. Imagine I give you a photocopy of an important document. You can take that copy, draw all over it, spill coffee on it, do whatever you want. But my original document, safe and sound in my desk, is completely untouched.
Pass-by-reference, on the other hand, that's like me handing you the one and only original document. There are no copies. If you make a change, you have changed the real thing, and that change is reflected everywhere. The stakes are way higher because you're messing with the source itself.
Okay, let's start with the easy part. Primitive types. Like integers, booleans, that sort of thing. With primitives, Java's pass-by-value nature is on full, unambiguous display. So here's our first test case. In our main method, we have two integers, x and y, with values 1 and 2. We pass them into a modify method that tries to change their values to 5 and 10. The big question is, back in the main method, what are the values of x and y after that method call? This table shows us exactly what's happening under the hood in memory. The original x and y exist on the stack. When we call modify, Java creates brand new variables x1 and y1 in a new part of the stack and just copies the values over. The changes to 5 and 10, they happen to these copies, not the originals. And the result is exactly what our photocopy analogy would predict. After the modify method is done, the original x is still 1 and y is still 2. They are completely, totally unchanged. So for primitives, it's a slam dunk. Java is clearly and simply pass by value. All right, that was the warm-up. Now we get to the main event, the part that causes all the confusion. Objects. This is where things get really interesting. Okay, here it is. This is the absolute key to understanding this entire concept. When you pass an object, Java is still passing a value, but the value is not the object itself. The value that's getting copied is the reference. It's the memory address that tells the system where to find that object on the heap. This means we need to upgrade our analogy. We are no longer photocopying a document. Instead, imagine the object is a house. We are not making a copy of the entire house. We are making a photocopy of a piece of paper with the address of the house written on it. Let's visualize this. Before we call our method, we've got a variable named a on the stack. Its value isn't the object, it's just a memory address. Let's say 0x123. That address points to the actual foo object, which lives over in a different area of memory called the heap. Now, when we call the method, Java's pass-by-value rule kicks right in. It creates a new variable for the method, let's call it a1. And what value does it put in a1? It puts a copy of the value from a, so a1 also holds the address 0x123. We now have two separate references pointing to the exact same object. And this, right here, this brings us to the final piece of the puzzle. Once you understand that we have a copy of the address, you can finally see the crucial difference between modifying the object and reassigning the reference. So, in our first scenario, inside the method, we use our copied address, a1, to find the house. Then we go inside and change something, like incrementing the num field. In our analogy, we followed the directions on our copied piece of paper, found the original house, and painted its walls a different color. And the result?
The object on the heap itself, the actual house, is now changed. Its num field is 2. And since both the original reference A and the method's reference A1 point to this one object, the change is visible everywhere. This is exactly why it feels like pass by reference.
But what if we try to reassign the reference itself? In this scenario, inside our method, we take our reference B1 and we point it to a completely new foo object. In our analogy, this is like taking our photocopy of the address, throwing it in the trash, and writing a brand new address on a new piece of paper.
This action only affects the local copy of the reference, B1. The original reference, B, is completely untouched. It still holds the address to the original object. Changing our photocopy of the address has zero effect on the original piece of paper. This is a really key design choice for safety. A method can't just secretly swap out the object you passed in.
So, having examined primitives and objects and that critical difference between modifying and reassigning, we can now put it all together and deliver the final verdict on this long-standing Java myth.
And the conclusion is clear and unambiguous. As the source material from Baldung puts it, as far as Java is concerned, everything is strictly pass by value. There are no exceptions to this rule. The confusion doesn't come from the rule itself, but from what value is actually being passed.
So let's lock this in. Here's your key takeaway. First, Java is always 100% pass by value, no exceptions. For primitives, it passes a copy of the actual value. For objects, it passes a copy of the reference value, the address. This means you can use that copied address to change the original object's internal state, but you can never use it to make the original reference variable point somewhere else.
So, now you know the mechanics, you know how it works. But that leads to a bigger question. Why did Java's designers choose this specific approach? As we saw, this decision prevents a method from unexpectedly swapping out an object you passed into it. It's a design choice that points to a core philosophy of safety and predictability, making code easier to reason about, even if it creates this famous point of confusion. Something to think about. Thanks for joining me.